Hello and welcome. Today we're going to go over the AP Calculus AB FRQ 2010 number 2 problem. Alright, so the problem is a zoo sponsored a one-day contest to name a baby elephant. The zoo visitors were able to deposit entries into a special box by the front of the gate between noon, t equals 0, and 8 p.m., t equals 8. The number of entries in the box at t hours after noon is modeled by e of t for the hours 0 to 8. It gives us some values for the hundreds of entries at each particular given hour, but it does not give us a function. So we're going to use these data entries to do our thing. So part A, approximate the rate at time equals 6, so at 6 p.m. The rate is the average of the two other rates next to t equals 6 because we don't have that exact rate. So e prime of t will give us the rate at time t. So e of 6 will give us, by taking the average of the rates on either side of 6, will give us 400 entries per hour at approximately, because we don't have the exact at 6. So there's 1 point for the answer, and there's 0 points for showing your computations, even though it asks for it. The only point you need is the answer, but you don't want to ball the answer. Part B, trapezoidal sum. So it gives you the formula 1 to 8, 1/8 of 0 to 8. So let's do a little bit of review of trapezoidal sums. So a to b is the interval of f of x. So let's say this is your graph. A to b is the height or the interval of the trapezoid, and so the area of the trapezoid is the interval because that's the height, and then the average of the two sides, which is how you would find the area of the trapezoid, and therefore how you would find a trapezoidal sum. So 1/8 of 0 to 8 e of t dt is equal to 1/8 times 2 times e of 0 plus e of 2 over 2, because 2 is and 2, 3, and 1 are the sizes of the interval, or therefore the height of those trapezoids. And then divided by 2 because we want the average of the two different bases. And then after that, you can just plug in the values as given in the chart of information we were given at the beginning of the problem. Therefore, we can find that it is 10.687 or 10.688. It's always better to go extra decimal places to ensure that you get the correct answer, because sometimes they will dock you points for having an incorrect rounded number. That number is the average number of entries in the box between 0 hours afternoon and 8 hours afternoon, which is 8 p.m. So the points that you can get for this problem. The first point is the sum. You have to set it up, and the trapezoidal sum, and make sure you do it correctly. And then second is the approximation, which is plugging in and finding the values that we were given from the beginning of the problem. And then the third point is from the meaning, where you have to explain. And it's always better to explain and not be vague to make sure you get the point by being completely accurate with your description. Part C. After 8 hours, they start processing the entries given by the function p of t. That is how fast they process those entries between 8 and 12 p.m., or 8 p.m. and midnight. By t equals 12, how many have not yet been processed? So it's first off, we have to establish right away that at time 8, 0 have been processed and 2300 have not been processed, which is given by the information in the beginning. So we have to subtract how many they do process from that 2300, so we can answer the correct question of how many have not been processed. To find this, we can just plug it into the calculator by pressing the math button, pressing 9 to get the integral, and then plugging into each of that section from what you can see on the screen, which will give us 16. So you know that there will be that many entries not yet processed by midnight. The points that you can get from this. First, setting up the integral, you have to make sure that you subtract it from 23 so that you're not finding how many they have already processed, and so you answer the question correctly. And then the second point is for the answer. They don't need to see the work that you did in the calculator. You can just plug it in after you write down that integral. Part D, how when are when are the entries being processed most quickly? The first step is you need to look for the critical numbers of the derivative of p so that you can find those rates, and don't forget to test the endpoints. That's absolutely necessary. So part one is to find the critical numbers of p prime of t where it equals 0, where the slope of p of t is 0. And then you plug those in to p prime of t, but make sure that you test the endpoints, because this will give us the rate of how fast they are being processed. So if you had just done 12, or if you just tested the middle points, you would think that 9.18 would be the quickest rate, but when you test the endpoints too, you can see that 12 was actually the time when there was the fastest rate. So at t equals 12, the rate is 800 entries per hour, which is the quickest processing. Okay, some points that you can get from this. First, you absolutely must state that p prime of 8 is equal to 0, because none were processed at that point, which establishes that you know that you had to subtract from 23 to get the correct answer. The second point is that you must identify all candidates, which just shows that you must test those endpoints. The third is that you must answer and justify your answer by plugging in those candidates all back into p prime of t to justify your answers. Some similar problems to this, in case you want a little bit more practice, are the FRQ 2013 number 3 and the FRQ 2006 number 4. I really hope that those can help you, and thank you so much for watching. I hope this video helped you. Please enjoy this elephant, the baby elephant that the zoo was trying to name.